We're looking at a question dealing with the resistivity of a conductor. We need to know the resistivity of the materials we're going to use in each of the conductors, and here we've got aluminium has a resistivity of 2.8 by 10 to the negative 8 ohms per meter, and copper 1.72 by 10 to the negative 8 ohms per meter. There is available these resistivities for every conductor out there. The ones we'll be dealing with mainly are aluminium and copper. You'll need not to know these figures. They will be given to you in exam questions. So let's look at this question here. What is the resistance of 100 meters of 6 millimeter squared copper cable? So we're going to work out the resistance of this conductor. First of all, we need to know the formula we're going to use. That's the formula there. The resistance is equal to rho L divided by A. R is the resistance of the material in ohms. Rho is the resistivity of the material in ohms per meter. And we've been given these up here, aluminium and copper. In this question here, we're really only interested in the copper. L is the length of the conductor in meters, and A is the cross-sectional area of the conductor in meters squared. It must be in meters squared. Right, we've been given most of this information here. We've got rho, we know it's copper, so we can get that up there. We've got the length, it's 100 meters, and the area, the cross-sectional area, that's 6 millimeters squared. We do have to convert that to meters squared though. Okay, let's put some quantities into the formula. So we're going to put rho there, 1.72 by 10 to the negative 8 ohm meters times 100 meters, and we're going to divide that by the area of the cable, which is 6 by 10 to the negative 6 meters per squared. It's really important that we times it by 10 to the negative 6 to convert from millimeters squared to meters squared. Once we've got the units put in there, we can put that into our calculator and get a result for resistance, or we can also do some cancelling if you're confident doing your cancelling, and that will change it to 1.72 divided by 6, which is a lot easier number to deal with. And the result of that is 0.286 ohms, which we can also express as 286 milliohms. If you're not getting that answer, there's a couple of traps that people fall into. One of them is not converting the millimeters squared to the meters squared, not putting the factor of 10 to the negative 6 in here. The other thing is a lot of people get into trouble loading this into their calculator. It's very important that this number here is loaded as 1.72 exp negative 8. You leave out the times 10. Likewise with this number here, we load that as 6 exp negative 6. Another thing you might want to be doing is putting this calculation in here, 1.72 exp negative 8 times 100, then pushing equals and dividing your result by this. That way you'll ensure that you're following BEDMAS and you're getting the answer that you require.